All right, so now we're going to talk about starters and some of the different components inside of a starter. So here we have the body of the starter with the field coils in there, and then deep inside you see the brushes. This guy, the armature, would sit inside of that unit, and the brushes would make contact with the commutator bars. These guys right here. So the brushes make contact with those bars. And then we have the drive component here, which actually engages the drive, and these gears here go in contact with the flywheel or flex plate and ensure that it actually starts turning the engine over. All right, so to start off, we have the body of the starter. When power is applied to this terminal, so this power get applied to this through the starter relay. So the relay would apply power to this. Power goes in through here, and then it gets connected through the field coils. These field coils would feed the brushes right afterwards in series. And there's going to be two field coils that are kind of in positive, and two field coils that are in negative. So I'll kind of explain. You get the field coils, the current will go through, and then you'll have two opposing brushes that are both going to be positive side brushes, and they're going to kind of touch the armature on edges like this, on sides like this, and then the ground ones would be 90 degrees from there, contacting the other two sides. So what that does is if we have power there and grounds there, those commutator bars are connected directly through these solders, through these ends here, and then to the wires, and it goes through this laminated core as a coil of wire that wraps around, goes back in, and creates a magnetic field inside the armature. Once the armature creates a magnetic field, it's going to get attracted to the field coils and these metal cores inside the field coils. So current will go through it, and then it'll get attracted to the field coils, so it'll end up turning slightly. But as soon as it turns slightly, then the brushes are going to contact the next commutator bar, which is going to move the magnetic field slightly further away. So as that rotates, the brushes keep contacting different commutator bars, which is slowly going to move the magnetic field ahead, and the magnetic field will constantly be attracted to these field coils, and that's what creates the rotation, is the constant attraction to the field coils from the magnetic field inside of the starter. As you can imagine, brushes will be flying over these very, very, very quickly. So these magnetic fields build and collapse extremely quickly as they build and collapse. If there's any issues with this, it might be very difficult to tell. And most of the time, it just has to do with measuring output. But as you're going to see, if we tested the commutator bars, I could maybe check this one. I don't have to go 90 degrees. I can go the one right beside it. And look at that. They're connected. And they're connected. They're connected. They're connected. All of these are connected to each other, just with the different terminals that are soldered on, and it just does a big loop, and it constantly does a big loop. So if you had an open in here, you'd have to have several opens in order to measure an open. So you wouldn't be able to measure an open in this unit, and that's why you don't really use a tool like this, like a meter, to measure an open. But what you would see, if you did have an open, then you'd have kind of one dead commutator bar, which would get a bunch of carbon arcing in there, and it'd be black like this. Now, This one didn't have a dead one, so I painted that. But just so you can kind of understand that it'd be a full black bar like that. If they all looked like this when you pulled it out, you'd be good just to clean it up with a little sandpaper, put some new brushes on, and that'd be good to use again. On the drive side, this gets a little bit interesting. On the drive side, many starters spin extremely fast, and that's to get the momentum and to use less electricity to get them going. But you notice these great big wraps around here, they're holding the wires in from flying out. That's really what their job is, because they spin so fast. Inside here, you see it's got a small drive, and then that small drive will work through some planetary gears, which the carriers would pin into those, which we don't have, and then that would turn this. So there's a gear reduction in a lot of starters nowadays to get it to a more usable speed. Once the starter kicks out, it's going to be turning like this, and you see there's some spiral coils on the shaft of the starter drive, and that's going to kick it out, help start it, and get it to start the rotation so that the teeth here can engage with the flywheel or the flex plate without damaging it. And the fork will help push on it and hold it out as well. Now, I don't have that component as well, but it will help hold it out and kick it out. And if the teeth do clash, it's got that spring in there to keep them from completely destroying them. Also, as soon as the engine starts, that flywheel or flex plate's going to start turning extremely fast. And if you keep holding the key on the starter, you're going to run into trouble with the engine now trying to turn the starter. And so what you'll find is this gear can turn one way, but then it locks the other way. So the overrunning clutch that's inside of here will help it overrun one direction, but then the other direction it's locked. So as it's locked, that's what's going to help turn the starter and get things rolling. And then when the engine starts, the overrunning clutch kicks in, and then that guy will back out. And as it backs out, then now your starting event is done and you can just continue driving your car along.